Hi everyone. Let's take a look and review a few things from algebra that we are going to use quite often in statistics, especially when we are working with two variable statistics, and the equation of a line is the important part. So first of all, you might recall from algebra an equation that looked like this, where we have two variables, the variables y and x, and we actually have some constants, some things that within the context of one problem are not going to change, and that is our slope and our y-intercept. So let's take a look at just some sample data that makes a really easy equation, and you can probably see the pattern, and that's what we're looking for in statistics. And as we're modeling data, we're looking for a pattern. Normally we have our x's and our y's, so let's just put in some sample x's here, like 0, 1, 2, 3, 4. All right, and the pattern I'm going to use for this is I'm going to double each number, and then I'm going to add 1, just to make it simple. So I'm going to double 0 and add 1. I'm going to double 1 or double the number 1 and add 1. So 2 times 1, 2 times 2 plus 1, 2 times 3 plus 1. I can do that. 2 times 4 plus 1. All right, so I put all of those things together, and let's take a look at how that looks when I have the data over here. So I'm gonna label it a little bit different. Let's go every 2. All right, and the same thing going up. So for each one of these, at 0, I have the 0.1. At 1, I have the 0.3. At 2, I have the 0.5. 3, I have the 0.7. And 4, I have the 0.9. Now you should recognize that all of these points make a perfect line. So I'm just going to use this little tool to draw a line through all of these points. All right, so they make that perfect line here, and let's make that line weight a little bit narrower so we can see them. So it's a perfect line that goes through here. This data is described by the equation y equals 2x plus 1. I am doubling every x value and adding 1. And so a couple of things to remember as you're looking at this when we talk about these things. Probably the most important constant here is the 2, also known as the slope. When you have something that has a slope of 2, when we talk about slope, just like you would think of a ski slope or an incline, a ramp, whatever it is, a lot of times people will refer to it as the slope is the rise over the run, which basically means how far up or down did this thing go, divided by how far left or right. And what's important to remember about this is that the slope is going to have a positive or a negative value. If I talk about going up, I'm usually talking about positive. If I'm talking about going to the right, that's positive. When I start going down or to the left, those values are negative. And so the thing to remember is that when you find a slope that has positive, I'm expecting that thing to go up and to the right. Positive means going up. Negative would be a line. If I had a line going in this direction, I would expect a negative slope. All right? So when I'm looking at this, a lot of times the fancy way of saying this, the rise over 1, is the change in y divided by the change in x. All right, I know what that's going to be for any point, and here's the nice part. When I start evaluating that, I can go from any point on this line to any other point on line, and let's look at what the change is. So from here to here, and I'm actually just going to count the squares. I'm not even going to worry about what the actual numbers are. I ended up going up 4 squares and over 2 squares. Positive because I was counting up, and positive because I was counting over. So my slope ends up being 4 divided by 2, which again shows me 2. Now I can do that with a much different approach. I could count the slope from 3 all the way up. Let's go all the way up to the very top, to 9. All right. Again, I could count the squares and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up, and 1, 2, 3, 4, 5, 6 over. I could just count the points. From 3 to 9, I have a difference of 6, and from what looks like 1, when I go this way, all the way over to 4, I have a difference of 3. Notice whichever way I did that. The first way, I would have the change in y is 12, the change in x is 6, still a slope of 2. If I counted by the actual numbers, 1, 2, 3, 4, 5, 6 up, and 1, 2, 3 over, I have change in y of 6, change in x of 3, still a slope of 2. No matter how you look at it, you're going to end up with a slope of 2. In fact, one last time, just to confuse everybody, I could start and do this the opposite direction. So let me grab a different color here. I could start right here at 7 and say, oh, I had to go down, and I'm going to go all the way down to 1, and then over. And let's just, for argument's sake, let's just see. From 7 down to 1, I went down 6. So that's negative 6. That's my change in y. From 3 over to 0, I went to the left 3. So that's negative 3. When I divide those, I still get a positive 2. So my equation, y equals 2x plus 1. The plus 1 is usually the easier part of that because it is the y-intercept. Where does this thing cross the y-axis? All right, so when you are looking at the equation, I see that it crosses the y-axis. A real line would continue on in both directions forever. There's a couple other things to kind of keep in mind when you work with a slope. If you ever have a line that goes straight across, that has a slope of 0. So I might have an equation like y equals 0x plus 3. What that equation really means is y will always be equal to 3. So let's say that this is my equation, and here's 1, 2, 3. We'll just put 3 right here. No matter what you put in for x, y is always equal to 3. All right, that's probably not going to happen as often as you would think when you're looking at statistics that you have a flat line, but it is possible that you have a slope of 0. The other slope that you could end up with that is also kind of unique is what's referred to as an undefined slope. If I have a line that goes straight up and down, let's grab this guy and pull him out here so that I have it somewhere. If I have this line that goes straight up and down, let's redraw it over here. We'll draw it right here. If I were to look at it, I have different points along this line. I'll label some of them. So 1, 2, 3, 4. We'll say this is the point 4, 0. Here's the point 4, 2. Here's the point 4, 4. You're going to notice something in common with all these points. Here's the point 4, 6. No matter where this point is drawn, x always equals 4. If I wanted to use what was called the slope formula and kind of figure out the slope of this line, I would say, well, how far up does it go? Well, let's go from here to here. It goes up 6. How far left and right does it go? Well, it went nowhere. 0. And this is undefined. We can't divide by 0. So we have an undefined slope. So in summary, really what you're going to be looking for and recognizing is positive slope, negative slope, zero slope, and undefined slope. And these equations will look weird because they will be y equals 3, for example, and this one would be like x equals 2. All right, so they won't necessarily seem to fit that same pattern of y equals mx plus b, where m is your slope.